Hi, my name is Russell Dent. I'm a grad student at the University of Rochester, and today I'm making this recording for future grad students in the department to do a summary of using the XPS to do depth testing in materials, that is, to get elemental compositions at different layers of a sample. Um, so I'm going to go through um, resources that are available that are free to help you quantify and understand the data that you're taking. And then I will go through a brief overview of the steps that are required to go from the output data from the XPS to using CasaXPS to finally generate a report of whatever you need into Excel, so that you can use it in presentations. So first, what we have here is probably my personal favorite website to go to in order for a first look at um, what you're seeing in an XPS dataset. So this is Thermoscientific's XPS sheet, and if you go to this website and elements table, you can pick out any element that you're trying to look for. So for example, silica or silicon, and then it'll tell you information about where the peak should be centered on, what types of peaks you're looking for example, like an oxide peak right here, and then general comments about how you would go about testing it, including a lot of times etching parameters, like what's good to etch it, what doesn't work so well. And then if you go to the bottom here, there's usually some good resources for further reading. Um, I won't go into these, but uh, in general, I would recommend reading some of these, especially this one, if you're um, looking for particular methods for looking at dielectrics. Anyway, so now we'll go to, let's say you've got your XPS results, you've done your depth test. You'll have a data set that looks something like this. Hopefully you have some surveys and you've got your regions. So in order to quantify what you're looking at, you usually will be talking about things in terms of atomic percent. Um, and from this right now, we don't have that, so we need to tell CasaXPS how to generate that. So one way to do it is to, you can see I already have a quantification here. We'll go over to this one, and to do a single quantification, you say quantify, and it'll bring up this thing, and all you have to do is hit create, and in a perfect world, that's it. But sometimes you might have stray peaks over here that are signatures from other elements that you don't want to capture. And in that case, you can just take your mouse and drag these lines to the region you want and maybe get a better idea. For this one, it doesn't really matter. But obviously, if you have that for this many data points, doing this for every single one individually is going to be a pain. Thankfully, we can do it for a bunch of data points at once. So if I click on this column and highlight the entire thing, and then I go over here to add regions, click it. It says existing regions will be deleted for the two that I already generated. That's fine. It'll create it for every single data point in the column. Now this is the quick and dirty way. You can always go through and double check that the regions you generated are capturing the peaks that you want to and not capturing the peaks you don't want it to. So you can always go through later with the quantification button and resize these for individual ones. But for our purposes today, we're just going to highlight these other three columns. We're going to add our regions. And now we have Hafnia. See how right here, this doesn't capture this peak because it knows that the peak should be around here. That's great for us. It makes our life easier. And we've got our oxygen, and we've got our carbon. Alright, so that's the fast and dirty way of doing the quantification of our peaks. So now, before I go into generating the reports, I want to talk about 3D viewing. Depending on what you're doing, it may be helpful to view this data as a three-dimensional function of binding energy, counts per second, and etching time. So in order to do that, it's very simple usually, but sometimes you have to mess around with some of the settings, and I'll talk about that. So if we want to look at the Hafnia peak over time as we etch it, we can select this column and then go over to this, which is insert many. Oh, we have to rescale first. So we're going to look at a place where Hafnia is larger, which this should be okay, I guess. Yeah, we'll use this one to start. We might have to pick a different one, but so we'll say insert. We'll highlight the column and insert many. And wow, that looks very ugly. Thankfully, we can click on this page. You have to click. I usually click in the white space up here, and you go up to 2D to 3D to FS. If we do that, now we have a slightly more understandable view, but because of the one we had highlighted before we switched, it'll keep that scaling on the counts per second. And so in order to change that, we go to Tile Display under Options, and we can change our axes. So if we just say 0 for that for now, and apply. Now we can see all this extra data that we have down here in case that's important to us. We can also scale this top one so that these peaks over here are captured. So let's say 800. Nope, gotta go even higher. 1,000. Alright, well that's good enough. So now we can see that this was the start, and we can see as we're etching in the sample we have an increased Hafnia peak. We won't talk about why that is in case this is a public video, but this gives us a very good idea of qualitatively of what's happening as we go further into our sample. We can do other things that might be useful to you. If we go back to Tile Display, you can change between binding energy and kinetic energy. You can rescale this x-axis so that you only capture, because we might not be as interested in the peak over here. Maybe we only want to capture the energies between 18 and 11 or so. So we can say 18. And now we can get a maybe slightly better view of what we're looking at with a 3D image. Another thing we can do is reverse the plot. This isn't as useful for this thing in particular, but if, for example, you have something that is degrading over time, like if you have carbon and the carbon's highest on the surface and then it slopes downwards as you etch into it, that will not be visible with this sample. So and you can hit reverse plot and apply, and now you have t equals 0 over here, and you have your final time over here. I'll show that in a second. For now, one other thing that you can do that is useful, and bear with me while I recall, is that you can offset your spectra to different degrees. That is not how we do that. That's not what I want. Alright, so off the top of my head I can't remember how to do that, so maybe I'll make a separate video for that. The last thing I wanted to say is that if you don't have so many data points, sometimes in your image you can use this display, the experimental variable on the right, and if I hit apply you can see that this is the etch time. I haven't figured out a way to make this font in particular smaller so that it's legible, so so I don't have any idea how to do that. But if you only have like 4 or 5 data points, it works well. So yeah, I'm gonna delete that now. So normally what I do is if I'm doing a 3D image, I just add the initial, final, and maybe label certain times that I think are important in a PowerPoint or whatever. Alright, so that's 3D viewing. Let me show you the carbon peak really fast so I can show you how that reverse plot works. So we got this guy and we hit insert, highlight the column, insert any. Now you see here that the initial peak is the highest, but it masks some of the information behind it. We don't want that. So if we go to tile display, geometry, reverse plot, and apply, now we can see, have a better idea of what's happening at the times right after that initial reading. So that is nice. Alright, so finally we'll move on to reporting. There are a couple ways that you can go about this. If you want to include a report in your survey, so let's say I have this survey here. Oh, we have to go back to 2D, so we'll click this a bunch of times and go back to our two-dimensional view. If we want a atomic percent table to appear on this image, it's fairly straightforward to do. Let's say we only want it for these first 1800 seconds of the etch time. If you do it for the entire thing, it'll make a table that's way too long, and that won't work. So you need to export that to Excel, which I'll show in a second. But for this, we can just highlight do tile annotation, quantification, regions, apply, and now you see that what's showing right here is the value that is given from just this one highlighted cell. But if I shift click here and add this one, since we said we were going to go to 1800, now it's showing all the silicon peaks, but we don't want just the silicon peaks because we're looking for atomic percent. So we're going to highlight these ones too. Ooh. There we go. And now, if you come back over here, you can see how the table trails off below. There's a way to rescale this. I'm not going to go over it. But you could theoretically fit this smaller amount of data in here better if you wanted to. But now you have your atomic percents automatically count, like scale to the 4 regions that you're looking at. So at the top we have silicon, carbon, oxygen, and then after 180 seconds of etching we have a new reading, 180 more seconds, etc., etc. So that's nice if you have less data points to just be able to show as part of your survey. We have a lot of data in this, so what we would like to do is export it to Excel, and then maybe further to Origin, if or whatever plotting software you use, and then be able to do whatever, generate whatever reports we want with the atomic percent values. So maybe we want to do a silica to oxygen ratio, or we want to show silicon to hafnia ratio, or I mean, at that point, you can do anything you want. But in order to do that, what we're going to do is we've done all of our regions for our silicon, hafnium, carbon, and oxygen. So when we go to quantify, we go over here to report spec, and we can do regions. Hold on a second. That's not what we want. So let's let's pull this back up. Alright. So we have to highlight these first. So we've got our 4 columns highlighted. Now go to here, report spec. Yeah, so now you see these columns are highlighted, standard deviations, etc., etc. So now if we do regions, now we've got a table generated which can be exported to a text editor like Microsoft Word or directly to Excel. And all you need to do that is go up here to this copy button, copy. You can select what you want to copy, or you can just copy all to clipboard and then change it. And we paste. And there we go, we've got a table. We can delete this so that it makes it easier for plotting. Delete these rows. And now we've got peak, position, full width, half mean, the raw area, and with the calculated percent atomic concentration, which takes all the factors of the measurement into account. So this is cool, but this is not a very good table if we want to plot things. So if I wanted to plot the silica atomic percent over time, what I'd have to do is I'd have to select this one, and 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 this one, etc., etc., all the way down. That's very annoying. You could write a macro to do it, but there's an easier way. So leave this for now. We're going to hit OK, and then we're going to go down here, and if I remember correctly, we can do an regions. There you go, area report. Now we've got etch time as the we can make it the x-axis, right? And we have our carbon percent, hafnia percent, oxygen percent, or silicon percent. So now if we copy this guy, copy all. This also doesn't have that well, it does have that information at the top. And if we Control A, take that, Control paste, do the same thing we did before. Now we have etch time and our atomic percents right there for us, and the counts per second at this is like the integration value. So if say we want to plot the hafnium concentration as a function of etch time, we just Control click on these 2 columns. Okay, and insert, and plot, and boop. That is not working for us. Why isn't that working? Maybe we have to say, if you hold Control Shift and the down button, it'll highlight this for you. I have not ever had this issue before. And then we'll Control click here, Control Shift down. And let's see if that works for us. I may have been trying to plot zeros because it should definitely work. Insert chart. There we go. Alright, so if we expand this a little bit, we can add some lines just to get a first idea of how this is changing with time. And yeah, there you go. This is showing the atomic percent of hafnium as a function of etch time. And obviously you can format this however you want, or take this data set and put it in Origin or whatever your preferred plotting software is. And and then you can generate a much more valuable report for a presentation than if you were to take if you were to just show a table like this. Okay, so that is all I had to say about generating reports from etch test data. I'm going to exit out of these for now. Thank you for watching. If this video does become public, please like this video so that other users can find it better on Google. This is a result of me watching many YouTube videos and muddling through the software and trying to figure out how it worked in order to be able to do this. I hope it was very informative, and I thank you for watching.